we've got a modulus question. Solve the inequality. The modulus of 2x plus 1 is less than or equal to the modulus of x minus 3. I like drawing little graphs for these modulus questions. Again, it's one of those things that I like doing it one way. I know that everybody else does it a different way. But my preferred thing is to do a little sketch of this and see what it looks like, and then solve the two parts of the equation. I'll maybe show you both ways. I know what you would do with this. I would say 2x plus 1. That's quite steep. It crosses at plus 1, so that's a line that looks something like. How can I do it like that? X minus 3 would be less steep, and it would cross. Well, it would normally cross at minus 3, so it would be a graph that goes like that. But this one is going to bounce because it's a modulus one and cross at plus 3. So this one is going to do. How can I draw it? Ooh, something like that. Is that all right? I've kind of got away with that, I think. And these points, this would be plus 1 and this would be plus 3. And so now what we've got to do is to work out, we're looking for the points where these intersect, which is there and there. And we want to know when is the blue graph underneath the black graph. And that's this bit here, it's in between these regions, so that's the bit we're looking for. It's looking good. This point here is where, well, it's where the negative branch of 2x plus 1 met the negative branch of x minus 3. Now actually, because they're both negative branches, I can ignore the negatives and just say 2x plus 1 equals x minus 3, which gives me x equals minus 4. And there's that point must be minus 4. My other point is where the negative branch of 2x plus 1 met the positive branch. No, it's the other way around. The positive branch of 2x plus 1 met the negative branch. So 2x plus 1 is minus x minus 3. So 2x plus 1 is minus x plus 3. So x is it? Have I done that right? I've lost my minus sign. Oh, so that's 3x is 2. So x is 2/3. That I feel happy with that. So that point is at 2/3, and so the region we're looking for is it was all equal to. So it's all equal to that bit. That's what Dave would have done. But Dave is well aware that 90% of students would not have done it that way. They would have said, faced with this inequality, let's think, instead of modulus, another way that makes things positive is squaring it. So let's turn it into a squared thing, and let's do 4x squared plus 4x plus 1 is less than or equal to x squared minus 6x plus 9. So that's 3x squared plus 10x minus 8. Am I doing this right? Which we're going to factorise. Again, we could do that thing of multiplying and factorising it, but actually looking at it, it's got to be 3x and x, isn't it? And then two things are multiplied to give 8. Well, what about if this was a 4 here, and this was a 2 here, knowing what the answer is? And that must be there. Like that, and there it is factorised. And so we've got critical values. If you remember the old days of doing quadratic inequalities back in Core 1, critical values of x is 2/3 and x is minus 4. And do a little sketch of your graph. It was a quadratic that does that. We wanted to know when it was underneath the axis. That's minus 4, that's plus 2/3. It's underneath the axis, less than 0, between those values. So that's the region that we're looking for between them. So we're going to end up by saying that in the same way. There you go. It's up to you which way you do it, and know which way you're probably going to do it. Isn't it slightly, it's a little bit more elegant to be drawing. Look at that graph, that's lovely, isn't it? No, not convinced. Right. Given that x satisfies this inequality, find the greatest possible value of the modulus of x plus 2. Oh, that is a good question. So, we're now, given that this statement is true, given that x is between -4 and 2/3, we are asked to find the greatest value of the modulus of x plus 2. Okay. Now we know that x plus 2, modulus of x plus 2, is a graph that is a straight line that does that V-shaped thing, doesn't it? It hits the axis and it goes up. So its least value is easy. Its least value is 0. It's 0 when x equals -2, so it is 0 in that range. We're interested in its greatest value. Well, because it's a straight line, it's not going to have turning points. So its greatest value is going to be at either end of that boundary, isn't it? Does that make sense? Because it can't have any turning points because it's a straight line. So all we need to do is to check either end of this region and see what happens at either end of it. So if x equals -4, the modulus of -4 plus 2 is 2. That's the modulus of -2, which is 2. If x equals 2/3, then the modulus of 2/3 plus 2 is the modulus of 8/3, which is 8/3, which is more than 2. That's its greatest value is 8/3, and we can do that with 2 and 2/3. Does that make sense? So what we've done is we've kind of, I might have even have been tempted to just say, let's do another little sketch, because we like our sketches of these things. X plus 2 is a graph that does that, except we're not drawing the whole graph. That points at -2. We're only drawing it between there and there, between -4 and 2/3. And actually, even my rough sketch has given me an idea here that the biggest point that it has in that region is there at 2/3, isn't it? And that's kind of what we're doing. So we're not thinking about we're not thinking about those bits. We're only thinking about the bit in between. There we go. And how do I get into the draw? And that's maths. Why I?